And now in this lecture we'll answer on two questions. On both questions we'll find out the area of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. This is quadrilateral ABCD. In this quadrilateral ABCD, side AB is parallel to the opposite side DC. And therefore this quadrilateral is defined as a trapezoid. The two parallel sides, that is to say AB and DC, are defined as the bases of this trapezoid, and the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. If we define the length of base AB as B and the length of base DC as A, then the area of this trapezoid ABCD is equal to A plus B, that is the sum of its two parallel bases, times the height h over 2. Again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually A plus B, times the height h over 2. The height h must raise 90 degrees with the two parallel bases. Okay, so a trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. And the height h must create 90 degrees with the two parallel bases. So in the first question, we find out the area of this trapezoid ABCD. It is given us the question that the perimeter of this trapezoid is equal to 16 units. That is to say, the sum of the lengths of all the sides of this trapezoid ABCD is equal to 16. Again, a perimeter is the sum of the lengths of all the sides of the trapezoid. Okay, so that is to say, AB plus AD plus DC plus CB, in total it is equal to 16. We also know that the length of side AB is 2 units. Those two angles are right angles. And we also know that side DC equals to side CB. Okay, so we define the length of side AD as A. That is to say, side AD equals to A units in its length according to our definition. Likewise, we will define the length of side DC as B. And because of the fact that side DC equals to side CB, side CB must be also equal to B units in its length. So the perimeter of this trapezoid is 16 units. That is to say, AB plus AD plus DC plus CB is equal to 16 units according to what is given in the question. AB equals to 2 units in its length according to what is given in the question, plus AD is A according to our definition, plus DC is B, plus CB is also B, and it is equal to 16. And again, if you found out that 2 plus A plus B equals to 16. Here we subtract 2 from this equation, and we get that 16 minus 2 is 14, and 14 equals to A plus B, that is A plus 2B. So A plus 2B equals to 14. Here we subtract 2B from this equation, and we get that A equals to 14 minus 2B. AD is equal to A is equal to 14 minus 2 units in its length. In the next step, we will do a construction, that is to say, from the vertex B of this trapezoid ABCD, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. By doing this construction, we're going to do quadrilateral AB, MD. Inside quadrilateral AB, MD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4-pieces angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4-pieces angle must be equal to 90 degrees in its size. So inside quadrilateral A, B, and D, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must maintain a rectangle in front of square. So we write to this quadrilateral ABMD is a rectangle because it has 4 right angles. So I wrote it down. Quadrilateral ABDM is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB must be equal to the opposite side DM. But AB is 2 according to what is given us in the question, therefore DM, the opposite side DM, must be also equal to 2 units in its length. Likewise, according to the sum rule, in the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. What is the length of this missing 97 MC? From the drawing, it is very easy to see that MC equals to DC minus DM. So I write it down. MC equals to DC minus DM. So MC equals to DC. DC is B minus DM. We just write down for now that DM equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2 units. So in the next step, I'll copy this right triangle BMC in a new page and we will implement the Pythagoras theorem. We will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a evaluation for Pythagoras theorem. So actually, this is the right triangle BMC that I covered from the original drawing. In this right triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared, that is the square of the hypotenuse, is equal to bm square plus mc square. BC is B, therefore BC square is B square, and it is equals to BM square. BM is 14 minus 2B, therefore BM square is 14 minus 2B square plus MC square. MC is B minus 2, therefore MC square is B minus 2 square. So in total we should find out that B square equals to 14 minus 2B square plus B minus 2 plus B minus 2 square. So here we open the brackets on this side of this equation and we get that B square equals to 14 minus 2B square. 14 minus 2B square equals to 14 square, that is 196, plus 2B squared. 2B squared is 4B squared. Minus 2 times 14 is minus 28 times 2b. Minus 28 times 2b is minus 56b. And we have also plus b minus 2 square. B minus 2 square equals to b square. Plus 2 squared, that is 4. Minus 2 times b times 2 is minus 4b. So here we have b square on both sides of this equation, so b square will get cancelled. After we cancel b square, on this side of the equation we left with nothing, that is to say 0, while on the other side of this equation we have 196 plus 4 is 200, and we have also minus 56b minus 4b is minus 60b, plus 4b square. So in total, if we found out that 0 equals to 200 minus 60b plus 4b square. Here we will divide this equation by 4, and we get that 4b square over 4 is b square, minus 60b over 4 is minus 15b, and we have 200 over 4 is 50. And it is equals to 0 over 4 is 0. So in total, if we found out that b square minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 14b plus 50 equals to 0, the variable that we are looking for is of course b. So x equals to small b. Small b is the variable that we are looking for in this quadratic equation, while capital B is the coefficient of this quadratic equation. Okay, capital B is the coefficient of this quadratic equation. And in our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the coefficient a equals to 1, the coefficient b, that is actually capital B, equals to minus 15. Again, capital B is the coefficient of this quadratic equation that is minus 15, while small b is the variable that we're looking for in this quadratic equation. And the coefficient c equals to 50. So the only thing that this have to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we'll find out the value or the values of small b, because x equals to small b, that is the variable that we're looking for in our specific quadratic equation. We'll do it now, and we get that x equals to b, so x by b, and b equals to minus b. Minus b is the coefficient of this quadratic equation, that is the coefficient b equals to minus 15. Therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is 50, so minus 4 times 50 is 200. So inside the root we have 225 minus 200 over 2a. A is 1, so 2a is 2 times 1, that is 2. So in total we found out that the variable that we're looking for, that is small b, in this number specific quadratic equation, is equal to 15 plus minus. Inside the root we have 225 minus 200, that is 25, divided by 2. So in total we found out that small b, that is the variable that we're looking for in our quadratic equation, is equal to 15 plus minus, and the square root of 25 is 5, divided by 2. So here we have two solutions that are possible for b. The first solution for b, we define the first solution for b as b1, and the second solution for b is b2. So the first solution for b, that is b1, is equal to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b, that is b1, equals to 10 units. And the second solution for b is b2, and b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b, that is b2, is equal to 5 units. Repeat again, the first solution for b is b1, that is 10, and the second solution is b2, that is 5. We know that AD is one side of this trapezoid ABCD, and the length of side AD is A. According to our definition, the length of side AD is A. And A equals to 14 minus 2B. So 14 minus 2B is the expression of the length of this side AD. And a length must be a positive number. That is to say, this expression must be a positive number. What is a positive number? It is a number that's greater than 0. So, therefore, what we found out that 14 minus 2b must be greater than 0. So here we will add 2b to this inequality, and we get that 14 is greater than 2b. Here we divide this inequality by 2, and we get that 14 over 2 is 7, and is greater than 2b over 2 is b. So in total we found out that B must be less than 7 units from one side. B must be less than 7 units from one side, but from the other side, according to the first solution for B, that is B1 is equal to 10. But we found out that B must be less than 7 units. If B must be less than 7 units, B cannot be equal to 10, that is greater than 7. Therefore, this solution is the correct solution. In case of the solution, we will take into account only the second solution for B, that is B2, that is equals to 5. B2 equals to 5. Therefore, the only solution for B is B equals to 5. According to our definition, DC equals to B and B equals to 5. Therefore, DC equals to 5. B equals to 5, and therefore DC equals to 5. AB equals to 2 units. AD equals to 14 minus 2B. B is 5, so minus 2B is minus 2 times 5, that is minus 10. In total, A equals to 14 minus 10, that is 4. So A equals to 4 units in its name. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid is equal to the sum of its two parallel bases times the height over 2. So the two parallel bases of this trapezoid ABCD are AB and DC. So it is AB plus DC, that is the sum of its two parallel bases, times the height over 2. The height of this trapezoid ABCD is AD. Why AD is the height? Because of the fact that the height AD creates 90 degrees with the base AB, and the height AD also creates 90 degrees with the other base DC. Therefore, AD is the height. So in total, we found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC, times the height AD divided by 2. AB is 2 according to what is given as the question, plus DC. DC is B and B is 5. So this is 5 times AD. AD is A and A is 4. So the height AD is 4 divided by 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if we found out that the area of trapezoid ABCD this is the area that we are looking for in this question, is equal to 14 square units. And that is the answer to the first question. And again, we should find out that the area of this trapezoid ABCD is equal to 14 square units. So we finish the first question. In the next step, I will present to you the second question and we'll solve the second question of this lecture. In the second question, our mission is to find out the area of another trapezoid but with the same name, trapezoid ABCD. But again, in the second question, we have to find out the area of another trapezoid with the same name, ABCD. So this is the trapezoid that we have to find out the area of it. So in this trapezoid ABCD, side AD equals to 2x units in its length, side BC equals to x units in its length, line segment AM equals to 3 units, line segment BM equals to 2 units. Those two angles are right angles, and this is angle AMB, that is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD, that is different trapezoid than the trapezoid of the first question. Okay? So, in the first step, we define the size of this angle, that is actually angle BMC, is alpha. So in the right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. DC is one side of this trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of this straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to the rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. In this case, it means that the sum of the angles of the upper side of the straight line DC at point M must be equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha plus this angle that is 90 degrees plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M, exactly according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we prove that those two right angles are similar to each other according to angle similarity rule. So why those two right angles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So we should prove that all the three angles of this big right triangle ADM are correspondingly equal to all the three angles of this small right triangle BCM, and therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. We should find out that this is the big right triangle ADM. And this right triangle ADM is similar. This is the sign of similar to the right small triangle, triangle BCM. According to angle angle, similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AD of this big right angle ADM over side MC of this small right angle BCM is equal to side DM of this big right angle ADM over side BC of this small right angle BCM. And it is also equal to side AM of this big right angle ADM over side BM of this small right angle BCM. So repeat again, from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. That side AD of the big right angle ADM over side MC of the small right angle BCM equals to side DM of the big right angle ADM over side BC of the small right angle BCM, and it is also equals to side AM of the big right angle ADM over side BM of the small right angle BCM. AD equals to 2x according to what is given as the question over MC. MC is the missing side, so we will leave it as it is, and it is equals to DM. DM is also the missing side, so we leave it as it is, over BC. BC equals to x units according to what is given as the question, and it is equals to AM, that is 3 units, also according to what is given as the question, over BM. BM is 2, also according to what is given as the question. So in total, we shall find out that two x over MC equals to DM over x equals to 3/2. So those two expressions are equal to each other, therefore we will create equation 1 from those two expressions that are equal to each other. So according to equation 1, we get that 2x over MC equals to 3/2. So I write it down. So 2x over MC equals to 3/2. So here we will multiply this equation 1 by MC, and we get that according to equation 1, two x equals to 3/2 times MC. Repeat again, 2x equals to 3/2 times MC, according to equation 1. So here we multiply this equation 1 by 2, and then we divide it by 3 simultaneously. And we get that according to equation 1, MC equals to 2 times 2x over 3. So we found out that MC equals to 2 times 2x is 4x over 3. So we found out that MC equals to 4x over 3 units instead. those two expressions are also equal to each other, therefore we get equation 2 from those two expressions that are equal to each other. So according to equation 2, we'll get that dm over x equals to 3 halves. dm over x equals to 3 halves. So here we will multiply this equation 2 by x, and you get that dm equals to 3x over 2. Again, dm equals to 3x over 2. So she found out that this is side dm that is equal to 3x over 2 units in its length. In the next step, I'll copy this right small triangle BMC in a new page, and we will implement the Pythagoras theorem on this right small triangle BMC. The hypotenuse BM equals to 2 units in its length, according to what is given as the question. BC equals to x, also according to what is given as the question. And just right now found out that MC equals to 4x over 3 units in its length. Here by PT is the progression for Pythagoras theorem. So actually, this is the right small triangle, BMC that I copied from the original drawing. According to the Pythagoras theorem, this right triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. So I write it down. BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4. And it is equals to BC squared. BC is x, therefore BC squared is x squared. Plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we found out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared equals to 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, 4x over 3 squared equals to 16x squared over 9. So 4 equals, here we multiply x squared by 9, and then we divide it by 9 in order to have a common factor with this expression, and we get that 9x squared over 9 plus 16x squared over 9 equals to 4. 9x squared plus 16x squared is 25x squared over 9 equals to 4. 25x squared over 9 equals to 4. So here we multiply this equation by 9. If I get this 25x squared equals to 9 times 4, that is 36. Here we divide this equation by 25 and get that x squared equals to 36 over 25. Okay, again, x squared equals to 36 over 25. Here we take out of this equation, and finally we get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, x equals to 6 fifths. Units in its length. And again, we should found out that x equals to 6 fifths. X equals to 6 fifths units in its length. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AD plus BC, times the height, that is DC, over 2. Again, the height is DC because it creates 90 degrees with the base AD, and it is also creates 90 degrees with the other base BC. So if we found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC, times the height DC over 2. AD is 2x according to what is given as a question, plus BC. BC is x, also according to what is given as a question, times DC. DC in total equals to 3x over 2 plus 4x over 3. All divided by 2. So in total, if you found out that the area of trapezoid ABCD equals to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. Two x plus x is 3x, so this is 3x over 2, and here we have 3x over 2 plus 4x over 3. So here we take 6 as a common factor out of those two expressions, and we do it by multiplying this expression, both the numerator and the denominator of this expression, by 3. And we get that 3x times 3 is 9x, and 2 times 3 is 6. Likewise, we multiply both the numerator and the denominator of this expression by 2, and we get that 4x times 2 is 8x, over 3 times 2 is 6. So you can see here that by doing this operation, we actually created a common factor of 6 from those two expressions that didn't have any common factor. So as we found out, the zero trapezoid ABCD equals to 3x over 2, and inside the brackets we have 9x plus 8x, that is 17x, divided by 6. So in total, the area of trapezoid ABCD equals to 3x times 17x over 2 times 6. Here we divide both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is x, so in total in the numerator we left only with x times 17x, and we have to divide the denominator also by 3. So 6 over 3 is 2, so in total in the denominator we left with 2 times 2. 2 times 2 is 4, so in the denominator we left with 4. In the numerator we have 17 times x times x. So in total, the area of trapezoid ABCD equals to 17 over 4 times x times x. We have already found out that x equals to 6/5, so we have to substitute x here by 6/5, and get that the area of trapezoid ABCD equals to 17 over 4 times x. X is 6/5, so we substitute x by 6/5. We have x again, so we substitute x again by 6/5. So in total, the area of trapezoid ABCD equals to 17 over 4 times 6/5 times 6/5. 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9, and you get that in total, in the numerator we have 17 times 9 over 5 times 5. 17 times 9 is 153, divided by, here we have 5 times 5 in the denominator, so that is 25. And 153 over 25 is equal to 6.12 square meters. And that is the answer to the question. I repeat again, we found out that the area of this trapezoid ABCD, that is the area that we are looking for in this question, is equal to either 153 over 25 square meters, so in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square meters. So we finish with the second question. In the next step, I will summarize the lecture. We'll start with the first question, of course. But before that, I repeat again on the definition of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. This is quadrilateral ABCD, and because of the fact that side AB is parallel to the opposite side DC, this quadrilateral is defined as a trapezoid. The two parallel bases, that is to say AB and DC, are defined, again, the two parallel sides, that is to say AB and DC, are defined as the bases of the trapezoid. So if we define the length of the base AB as B and the length of the base BC as A, then the area of this trapezoid ABCD will be equal to the sum of its two parallel bases, that is actually A plus B times the height edge over 2. So the area of a trapezoid is equal to the sum of its two parallel bases. In this case it is A plus B times the height edge over 2. The height edge was created 90 degrees with the two parallel bases. You can see here that the height edge creates 90 degrees with the base AB, and the height edge also creates 90 degrees with the other base DC. So a trapezoid is quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. And the height must rest 90 degrees with the two other bases. Okay, so in the first question, I found out the area of this trapezoid ABCD. So in the moment we have this trapezoid ABCD. We know that the perimeter of this trapezoid ABCD is 16. What is the perimeter? A perimeter is the sum of the lengths of all the sides of the trapezoid. So the sum of the lengths of all the sides of this trapezoid is 16. That is to say, AB plus AD plus DC plus CB equals to 16. Okay, again, the perimeter of this trapezoid is the sum of the lengths of all the sides of the trapezoid. That is to say, it is AB plus AD plus DC plus CB, and it is equal to 16 units according to what is given as the question. AB is 2 according to what is given as the question. We define the length of side AD as A, we define the length of side DC as B, and because of the fact that BC equals to CD according to what is given as the question, and DC is B, therefore BC must be also equal to B. So AB is 2 according to what is given as the question. AD is A according to our definition. DC is B also according to our definition, and CB is also B. And it is equal to 16 because the perimeter of trapezoid ABCD is 16 units. Here we subtract 2 from this equation. We found out actually that A plus B plus B, that is A plus 2B equals to 16 minus 2, that is 14. Here we subtracted 2B from this equation and finally found out that A equals to 14 minus 2B. Okay, again, AD is equals to A is equals to 14 minus 2B. Okay, so in the next step we did a construction, that is to say, from the vertex B of this trapezoid ABCD, we drew perpendicular on DC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. By doing this construction, we can identify quadrangle AB MD. Inside this quadrangle AB MD, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle, in total they must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees inside. So inside quadrangle ABMD we have 4 angles, and according to rule 5, any quadrangle that has 4 angles must be a rectangle cut a square. So in order to this quadrangle ABMD, it's a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle ABMD, the side AB must be equal to the opposite side DM. But AB is 2 according to what is given as the equation, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B in its length. What is the length of this missing line segment MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, that is B, minus DM, that is 2. So in total, MC equals to B minus 2 in its length. In the next step, we copy this right triangle BMC in an equation, implemented the Pythagoras theorem, this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the square of the perpendiculars. So okay, this is the right triangle BMC that I got from the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equals to BM squared. m is 14 minus 2b, therefore m squared is 14 minus 2b squared plus mc squared. mc is b minus 2, therefore mc squared is b minus 2 squared. So in total we should find out that b squared equals to 14 minus 2b squared plus b minus 2 squared. So in the next step, we open the brackets on this side of this equation and finally found out that b squared equals to 14 minus 2b squared. 14 minus 2b squared equals to 14 squared, that is 196, plus 2b squared, that is 4b squared, minus 2 times 14, that is minus 28, times 2b. Minus 28 times 2b is minus 56b. And we also plus b minus 2 squared. b minus 2 squared equals to b squared plus 2 squared, that is 4, minus 2 times b times 2, that is minus 4. So in total we found out that b squared equals to 196 plus 4b squared minus 56b plus b squared plus 4. So here we have plus 4 minus 4b. Here we have b squared on both sides of the equation, so b squared will get cancelled. So in this side of the equation we left nothing, that is to say 0. While in this side of the equation we have 196 plus 4, that is 200, and we also minus 56b minus 4b is minus 60b, and we have here plus 4b squared. So in total we should find out that 0 equals to 200 minus 60b plus 4b squared. Here we divided this equation by 4 and finally found out that b squared minus 15b plus 50 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus 4 to b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is small b. Small b is the variable that we are looking for, while capital B is the coefficients of this general quadratic equation. In our specific quadratic equation, the coefficient b equals to minus 15, and small b is the variable that we are looking for. That is to say, x is the variable that we are looking for in this general formula, while in our specific quadratic equation, this specific quadratic equation, the variable that we are looking for is b. So x equals to b, the coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. So the only thing that is left to do is to put this data of our specific quadratic equation inside this formula. In this way we find out the value of the values of small b, because x equals to small b. So actually we already done it, and we found out that x equals to b, therefore x equals to small b squared, so we substitute x by small b, and it is equals to minus b, minus capital B. B is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is 50, so minus 4 times 50 is minus 200. So inside the brackets we have 225 minus 200 divided by 2a. A is 1, so times 1 is 2. So in total we found out that b equals to 15 plus minus, and 225 minus 200 is 25, so inside the root we left only with 25 divided by 2. So we found out that b equals to 15 plus minus, and the square root of 25 is 5 divided by 2. So here we have two solutions that are possible for b. The first solution for b will be b1. And b1 is equal to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1 that is equals to 10, and the second solution for b is b2 that is equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b that is b2 is equals to 5 units. We know that AD is one side of this trapezoid ABCD, and according to our definition, AD equals to A units in its length, and we already found out that A equals to 14 plus 2B. Again, AD equals to A, and A equals to 14 plus 2B. So 14 plus 2B is the expression for the length of side AD. And a length must be a positive number. What is a positive number? A positive number is a number that is greater than 0. That is to say, 14 minus 2b must be greater than 0 because it is an expression for the length of AD. So 14 minus 2b must be greater than 0. Here we added to this inequality 2b, and we found out that 14 is greater than 2b. Here we divided this inequality by 2, and we found out that 14 over 2 is 7, is greater than 2b over 2, that is b. So in total we found out that b must be less than 7 units from one side, but from the other side, according to the first solution for b equals to 10, that is greater than 7. But b must be less than 7. So we cancel this solution, and we left only take into account the second solution that is possible for b, that is actually b2 that is equals to 5. So we found out that b equals to 5, that is the only solution that is possible for b. If b equals to 5, we know that CD DC equals to b according to our definition, and b equals to 5. Therefore, CD equals to 5, AB equals to 2, and AD, the height AD is 4. Our mission is to find out the area of this trapezoid ABCD. So the area of trapezoid ABCD, according to the formula that I presented to you at the beginning of the lecture, the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC, times the height AD over 2. Okay, again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC, times the height AD over 2. AB is 2 according to what is given as a question, DC is 5, and AD is 4. So in total, we found out that the area of trapezoid ABCD equals to 2 plus 5 times 4 over 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So we found out that the area of this trapezoid ABCD, that is the area that we are looking for in this question, is equal to 14 square units. So we finish with the first question. In the next step, I present you the second question, and we solve the second question of this lecture. In the second question, we have to find out the area of another trapezoid. It is another trapezoid, but with the same name as the first trapezoid, that is ABCD. Okay, so in the drawing we have another trapezoid ABCD. We know that side AD equals to 2x units in its length, side BC equals to x units in its length. This is line segment AM, this is equals to 3 units. Line segment BM equals to 2 units. Those two angles are right angles, and this is again A and B, this is also right angle. Again, our mission is to find out the area of this trapezoid ABCD, that is totally different trapezoid from the first trapezoid. Okay, so first of all, we define the size of this angle BMC as alpha, so in the small right angle BMC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. We know that DC is one side of this trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the other side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees, according to all three, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of this at point M? We have this angle that is alpha, this angle that is 90 degrees, plus this third BC angle. In total, the sum of those three angles must be equal to 180 degrees according to all three. Therefore, this third BC angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M according to all three. So this third BC angle must be equal to 90 degrees minus alpha. In the next step, we focus on the big right angle ADM. On the big right angle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third BC angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, it is the sum of the angles in any triangle. So in the next step, we prove that those two right angles are similar to each other according to angle similarity rule. That is to say, we prove that this big right angle ADM is similar to this small right angle BCM according to angle similarity rule. So why those two right angles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if we found out that all the angles of the big right angle ADM are correspondingly equal to all the angles of this small right angle BMC, and therefore those two right angles are similar to each other according to angle similarity rule. So if we found out that the big right angle ADM is similar, this is the sign of similar to the small right angle BCM according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive the side AD of this right angle ADM over side MC of this small right angle BCM is equal to side DM of this big right angle ADM over side BC of this small right angle BCM, and it is also equal to side AM of the big right angle ADM over side BM of this small right angle BCM. And again, if we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is equal to DM. DM is also the missing side, so we leave it as it is, over BC. BC is x according to what is given as a question, and it is equal to AM, that is 3, over BM, that is 2, according to what is given as a question. So in total, we should find out that 2x over MC equals to DM over x equals to 3/2. Those two expressions are equal to each other, therefore we get equation 1 from those two expressions that are equal to each other. So according to equation 1, 2x over MC equals to 3/2. 2x over MC equals to 3/2. Here we multiply this equation 1 by MC, and found out that 2x equals to 3/2 times MC. Here we multiply this equation by 2, and then we divide it by 2, we multiply it by 2, and then we divide it by 3 simultaneously, and finally found out that MC equals to 2 times 2x over 3. So MC equals to 2 times 2x, that is 4x over 3. So if we found out that MC equals to 4x over 3 units. Those two expressions are also equal to each other, therefore we get an equation 2 from those two expressions that are equal to each other. According to equation 2, dm over x equals to 3 halves. Again, dm over x equals to 3 halves. Here we multiply this equation by x and finally found out that dm equals to 3x over 2. This is line 7 dm, that is equals to 3x over 2. In the next step, I copied this right small triangle BMC in the new page and implemented the Pythagoras theorem on this small right triangle BMC. So this is the small right triangle BMC that I copied from the original drawing. In this right triangle BMC, according to the Pythagoras theorem, BM square equals to B square plus MC square. Again, BM square equals to BC square plus MC square. BM is 2, therefore BM2 is 2 squared, that is 4, and it is equals to BC square. BC is x, therefore BC square is x square, plus MC square. MC is 4x over 3, therefore MC square is 4x over 3 squared. So in total, we found out that 4 equals to x squared, and 4x over 3 squared is 16x squared over 9. So if you found out that 4 equals to, here we have x squared. So we multiplied x squared by 9 and then we divided by 9 in order to overcome factor with this expression. We finally found out that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared over 9 equals to 4. Again, 25x squared over 9 equals to 4. Here we multiply this equation by 9 and finally found out that 25x squared equals to 9 times 4, that is 36. Here we divided this equation by 25 and finally found out that x squared equals to 36 over 25. So here we took out of this equation and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So x equals to 6/5. Found out that x equals to 6/5. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases. This trapezoid ABCD is AD plus BC times the IDC over 2. So if you get the area of this trapezoid ABCD must be equal to the sum of its two parallel bases. It is actually AD plus BC times the IDC over 2. AD is 2x plus BC. BC is x. According to was given as a question, times DC. DC in total equals to 3x over 2 plus 4x over 3. And again, DC in total equals to 4x over 3 plus 3x over 2. All divided by 2. 2x plus x is 3x, so we have 3x over 2. Here, actually, we took out 6 as a common factor from those two expressions, and we did it in the following way. We multiplied both the numerator and the denominator of this expression by 3, and found out that 3x times 3 is 9x, and 2 over 2 times 3 is 6. And likewise, we multiplied both the numerator and the denominator of this expression by 2. And finally found out that 4x times 2 is 8x, and 3 times 2 is 6. So in this way, we created a common factor of those two expressions. So in total, if you found out that 2x plus x is 3x, and we have here 9x squared, 9x plus 8x is 17x. We have to divide it by 2 times 6. So here we divided both the numerator and the denominator of this expression by 3, and finally found out that 3x over 3 is x, so in total in the numerator we left only with x times 17x, while in the denominator we have 6 over 3 is 2, so in total in the denominator we left only with 2 times 2. So in total the area of trapezoid ABCD equals to x times 17x over 2 times 2. But we already found out that x equals to 6/5, therefore we can substitute x here by 6/5. We did it and we found out that x 17x times x equals to 2 times 2, that is 4. So we have here x times x, so we substitute x times x by 6/5. And we found out that 17 over 4 and x is 6/5, and we have x again, that is 6/5. Okay? So in total, if you found out that the area of trapezoid ABCD equals to 14 over 7 times 6/5 times 6/5. Here, 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9. So in total, in the numerator we have 17 times 9 over 5 times 5, that is 25. 17 times 9 is 153, divided by 5 times 5, that is 25. So if you found out that the area of this trapezoid ABCD is equal to either 153 over 25 square units, in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 units, 6.12 square units. And again, the area of this trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.